Okay, sorry guys. The last one wasn't quite as short as I thought it was going to be. I put a clock in front of me today so that we won't go over that 20 minutes. Okay, so I'm trying to keep them short, so just bear with me. I did want to show you something that I thought, well, maybe they'll figure it out. It's okay. But something in your calculator that's really neat. So if you have your calculators, if you've got your graphing calculator, it comes in very handy. You might have seen on page 171 that there's a quick shortcut to finding them in a calculator. So I'm going to pull up my calculator really quick. If you remember the problem we did yesterday with the e to the x cosine x. So I'm going to write that here. So if your y equals e to the x cosine x, and we were trying, oops, I'm making lots of extra marks on the board today. I'm not using my pen, and I probably should. If you've got this, and we're trying to find y prime, and it gave you a number, these were f of x, I realize that now, of 1.2. Okay, you can actually go in your calculator and do this. Take the derivative and plug in a number at the same time. Are you with me? So we're going to hit the math button. And also, if you notice on my screen, you can see the buttons that I hit. I'm going to go down to number 8. You see it says in deriv. Okay, so I'm going to hit the number 8, and it pulls this wonderful box up. If you have the newer calculator, the 84, this will happen. If you don't, then you have to plug it in like it shows on page 171, the TI-83s. Okay, you're still going to put your function, then you're going to have with respect to x, and then you're going to put the number in. This one I'm going to put it with x because that's the variable we're taking the derivative of. Okay, then I'm going to put my function in, e to the x, second e raised to the x, do an arrow over, and then cosine x. I'm going to get out of that. I'm going to go over here to this box. I'm going to plug in 1.2. Okay. If you are in the TI-83s, you had to put the function in first. Then you had to use a comma to put in the x, and then another comma to plug in the number. So putting in the same thing. And I'm going to hit enter. And I believe that's the number we came up with yesterday at the end of our session. Okay, it's there. You had to do one of these overnight. So let's look at your number 5. Evaluate f prime of x. So your number 5 was f prime of negative 2, where f of x equal x squared natural log absolute value of x. Can you read that? Sorry, I'm at the bottom of the page. Now, let's go ahead and do the same thing. I'm going to the math page. Hitting number 8 for the derivative. I'm taking it with respect to x is my variable. My function is x squared. Natural log. Now, that x is an absolute values. Is that going to matter? It actually is. So I'm going to go back to my math button. I'm going to go over to the numbers, and that ABS, that's what it stands for, absolute value. Yes, I'm going to hit that. So it pulls up my absolute value, and I'm putting the x inside of it. I'm going to go all the way out, so I have x equals a negative 2. Okay, this should have been your number 5. I'm going to hit enter, and this should have been the answer you got. I did think, what if I just didn't plug in the negative? What if it was just a 2? Because x squared, negative 2 squared is going to be the same as if it is 2 squared. But if you remember the rule about the product rule, when we take the derivative of that to x, that won't be squared. So you should get a negative 4.77 for your number 5. Okay, just a little shortcut of something you can do on your calculator. Remember, if you don't have a calculator, please send me a note. I can get you the TI website that they are allowing you to have access for free right now. Okay, very good. Just let me know. we are going to continue and talk about the product rule some more. Okay? We're going to talk about differentials. What in the world are differentials? Do you remember? It was the dy equals. It's when we are solving for dy. Okay? So if my y equals that 5x squared, what is dy? So we would have done the derivative. Dy dx equals 10x. But when we just want dy by itself, what do we do with this dx? We multiply both sides by dx. Okay? These cancel. We multiply this side by dx. We just have 10x dx. So dy in this case would equal 10x dx. So it just means we're multiplying by dx. So how does that change stuff with the product rule? It doesn't that much. But let's look at a few things. It says the definition says the differential of the product of two functions is the first function times the differential of the second plus the second function times the differential of the first. So let's look back. I like the function, the derivative of uv with respect to x. Okay? Equals, so this was what I wrote yesterday, u times the derivative of v, dv dx, plus v times the derivative of u. Okay? Now what happens if I just want dx by itself? Because I'm going to multiply this side by dx. I'm going to multiply this by dx. If you multiply one, you must multiply them all by dx. Well, what happens? These dx's cancel. So it's the derivative of uv will equal. Well, what about this dx right here? Can it cancel with that dx? Of course it can. It's now u dv plus, what about this dx? Can it cancel? Yes, it can. V times du. Okay, that's one way to look at this. And actually is pretty simple. So this is the differential. Probably misspelled that. I did, that's an R. Differential of the product rule. This is the notation that we would use for the differential. Okay? So let's look at some examples. Change colors back. So let's say we're going to let s equal x squared y cubed. You may notice that I've used an x and a y. I want to find ds. So when it just asks you to find ds, it's saying I need you to find the differential. Okay? Our product rule is still first differential second plus second differential first. So first d second plus second d first. Am I still going to go to the side and write my u? You bet I am. What is my first function? It is x squared. Okay? What is the differential? So instead of writing du dx, I'm just going to write I'm going to go ahead and write it like this the first time. Du dx equals 2x. But is that the differential? What do we have to do? Multiply or take that dx to the other side. So my du is simply 2x dx. Okay? So what is my v? It is my y cubed. So what's the derivative of dv? Now is it going to be dx? Is that the variable I'm taking the derivative of? No, it's y. So we kind of have to catch ourselves right there to put a dv dy. What's the derivative of y cubed? It's 3y squared. But what is the differential? We need to multiply both sides or take that dy over. So dv is simply 3y squared dy. Okay? One thing you should notice, the variable and the dx, they have to go together. Variable is y, so you have a dy. Okay? So let's go ahead and find our ds. So we have first x squared times the differential of the second, which is 3y dy. That's my differential of my second, plus second, which is y cubed, differential of my first, which is 2x dx. Now, sometimes they will rewrite this and not put parentheses. I put parentheses, they don't always, but you don't have to have it because it's really just three things multiplied together. So I'm going to write, you could write this as x squared. Oh, wait, I'll tell you what they're going to do. They're going to put the coefficient out front is what they will do. You can leave it like this. It does not matter to me. 3x squared y dy. Plus, now here they're going to pull the coefficient and they're going to put x's in front of y's. Okay? I actually like it like this a little better. It shows me that you see the first, second, and the second and first. Okay? But know that sometimes they will write it like this so that you're not confused. Okay? That they could go back and forth. All right, one more example. If y equals s squared sine t, can you find dy? What is dy? Every time, guys, I'm going to the side, I'm writing what is my u, what is my v. Okay? U equals s squared. I'm going to say what is du. I'm going to skip that step this time. If you need to write it, please go ahead and write it. What's the differential of s squared? It's 2s. What's my term here? ds. They must match. Okay? What about v? What is my v? The second one, it is sine t. What is the differential of sine t? dv equals, the derivative is cosine t dt. They have to match. All right? So what is dy? First, d second, plus second, d first. Okay? All right, your problem for today with the differential. We won't have a ton of these. Your problem is number 6. Problem number 6 from lesson 31. Okay? And it says, find ds where s equals 2x squared y. Okay? I am going to go ahead because there's only one of these to give you some review problems. Okay? So your review problems from lesson 31. Let's scroll. Will be 7 through 12, 19, and 20. Okay? Let me know if you don't have your book yet, and I'll send you a copy of the pages, okay? I love you all. I miss you still. Bye. figure out how to turn it off now. Bye.